Hello, grade 11s, and welcome back to another lesson of functions, where today we will be looking at the domain and range of different functions. We will be looking at both quadratic and linear functions today. Our focus is not to graph these functions, so sometimes I will provide the graph for you, and we will only be looking at how to find the domain and range and what that means for our functions today. Our first problem that we are given is the following. A flare is shot vertically upward. A motion sensor records its height above ground every 0.2 seconds, and the results are shown in the table. The data which is plotted in that graph that you see on the right, and the function that we are given is height of t is equal to negative 5t squared plus 10t. And height is given to us in meters, and the time is given to us in seconds. And it does tell us also that the time is from when the flare is first shot into the air and the time that it returns to the ground. And we are asked, how does the motion of the flare affect the domain and the range of the quadratic function? Before we answer that, let's review what domain and range were. Domain will be the set of all possible values for our independent variable. So here our independent variable is time because the height of the flare does not depend on time. Time will be independent here and will continue regardless of the flare, but the height of the flare is dependent on time. We do care about as the time goes by, the flare will be moving up and eventually it will go down and land back on the ground. So what are the possible values of our time here? We do not know that our time can be the set of all real numbers, but specifically for this problem, we care about the time where the flare goes from the ground up into the air and back down on the ground. And if we look at our table of values here, we can see that at time equals 0 seconds, the flare shot up. And if we are looking at the height here, we will see that at time t equals 1 at 1 second, the flare has reached its maximum height of 5 meters and it goes back down, and at t equals 2 seconds, the flare has landed back on the ground. So the time the flare is launched and the time it lands affects the domain. So here, that will be the time between 0 to 2 seconds. Now, what about the range? So the range will be the height, and again, it's from the moment that the flare takes off and lands, the height that it has, which is 0 meters here, the maximum height that it reaches, which is 5 meters, and this will be our range. But how do we present that mathematically? Let's look over here. So we will be, as we said, it's a set, so we do need our set symbol there. And t is included in the set of real numbers. But as we mentioned, we have a restriction based on the problem here, which is the height of the flare in the air. So the t that we have here can be between 0 and 2 inclusive, because we also care about the time that it is shot from the ground and the time that it lands back on the ground. Similarly, for the height, we can also have that the height is in the set of real numbers, with the restriction being that height is inclusive to between 0 to 5, which means that it starts from the ground at 0 and the maximum height will be 5 here. Now, let's look at another problem where we will just have a quadratic function. So here, we are given the quadratic function y equals 3 times x minus 2 squared plus 3. Again, I mentioned we are not focusing on how to graph today, but we will be remembering some of our translating of our functions. So here we are starting with our simple quadratic function of y equals x squared. We will be using negative 2, what we know here, to move this 2 units to the right. And we will go up 3 units over here, and we will stretch by a factor of 3, which is our coefficient of 3 at the beginning. And if we do that, we will get this new function here. And now, if we are looking at the domain and the range, we can see that x here can be any value. We do not have a restriction on x. X can be the set of all real numbers. So here, for the domain, we will have the set x is in the set of real numbers. And again, because we don't have a restriction, we will leave it at that. Next, for our range, we also have that y can be in the set of real numbers. But here we have a restriction. If we look, y here we have at 3, and in our function, all possible values of y will be greater than 3. So for our restriction, we will put that line, and we will have y is greater than or equal to 3. And that will be the domain and range for this function. We will move on now to linear functions. So here we are given the two linear functions. The first one, y equals negative 3x plus 4, and the second one, y equals 5. So I've used Desmos to graph these two functions. You can also use this tool for this section because we only care about finding the domain and range, not your ability to graph. So for this first function of y equals negative 3x plus 4, I hope that you can see that x is in the set of all real numbers, and we don't have any restriction for x. X can be any real number. And based on that, our y value can also be any real number. And we do not have any restrictions for y here as well. But if we look at the second function, the blue line, which is our y equals 5, and that is a horizontal line here. So here, we can have all possible values of x as well. But for any value of x that we have, our y will be 5. Y will never change. And so when we have our range, y is in the set of real numbers with the restriction that y is 5 at all times. And that's how we would represent the domain and range for two linear equations. So we saw now a horizontal line. What do you think the domain and range of a vertical line would be? So if I have my plane here, let's think of this vertical line here, which will be x equals, let's put it, x equals 3. So here, the vertical line can have all possible values of y, but it will always be x equals 3. So our domain will be x is in the set of real numbers, and x will always be 3. However, okay, there we go. And for our range, y will be the set of all real numbers, and we don't have any restriction here. Y can be the set of all the real numbers, but x will always be 3. So do pay attention when you are looking at vertical and horizontal lines. There is a little bit of a challenge with them, but with all other linear lines or linear equations that are not horizontal or vertical lines, you will have the domain and range be the set of all real numbers. So x and y can be all real numbers, except for horizontal or vertical lines. Now let's look at a real life application where we will have restrictions for our domain and range. So here, a baseball thrown from the top of a building falls to the ground below. The path of the ball is modeled by the function height of t equals negative 5t squared plus 5t plus 30, where height of t is the height of the ball above ground in meters, and t is the elapsed time in seconds. What are the domain and range of this function? So here, I've graphed the function again on Desmos for you. So the plus 30 that we have here would be representing the height of the building. So when we are standing at the top of the building, and that is our time 0, we have a height of 30. And we throw the ball up, it does go a little bit up, we can see. So the maximum height is not actually 30, it does reach a height that is higher than that. And then it goes back down. And at time 3, we have landed back on the ground. So here, we would have, for our domain, which is T, T will be the set of all real numbers. And T starts at 0. So our time starts at 0, and at 3 seconds, it has landed back on the ground. So because we care about, in this function, we care about the time in which the ball is in the air, we will be restricted for T to be between 0 and 3 inclusive. Now, for our range, which will be the height, we also have that it is in the set of all real numbers. And again, we have a restriction. So the height here, while we do start at 30, it goes up to a maximum of 31.25, and it reaches a minimum of 0 because it does not land back on the roof of the building, it lands back on the ground, which has a height of 0. So here, we will have the height be between, oh, between 0 and 31.25 inclusive. And that would be your final answer for this problem, represented mathematically. So, to summarize, the domain was the complete set of all possible values for our independent input, which is x, typically, or the value that is on our x-axis. And the range will be the set of all possible dependent output values, and that will be dependent on our x value or our input or our domain. So in real life applications, there will be restrictions sometimes on the domain and range. Values that don't make sense will be excluded because we are applying meaning now to this math. And we looked at linear functions today. Again, a reminder, typically linear functions will have the set of real numbers as their domain and range, with the exception of horizontal and vertical lines. So today you're going to get some practice with domain and range of different functions. And if you have any questions, I will be happy to help. Happy learning!